Hello everyone, this is Dr. Monica Shaha, and this in this series we wanted to describe few design aspects in the control system. So let's start with the preface, which talks about what was the outcome from the in-class assignment given, and we have found that we have obtained system schematics for the water tank system. Please note that there are many simplifying assumptions were involved to keep the model simple and still approximate all the physical reality involved. Once it is done, the question comes in my mind that what should be the next job. So to answer this, let's have a look on the steps of the design process. So the design approach in the control system involves few of the steps, where first step was to transform the requirements into a physical system so that a control system engineer can look into the problem very deeply. Then step 2 involves to draw the functional block diagram and as well as create a schematic. That already has been covered in the RC1, which is resource creation assignment 1. The next important step was to develop the mathematical model, or what we say either in block diagram or signal flow graph. Step 5 involves reduce the block diagram, simplify the block diagram. Next is we have to examine the solution as well as the whatever the assumptions we have carried to derive the expression, derive the solution. Now the last and foremost important step involve that we need to reanalyze if the solution is not satisfactory and then proceed with the design. Now the journey from the schematic to mathematical model we wanted to discuss here, because already we have discussed about the schematic diagram, and we first wanted to say that the process of obtaining the desired mathematical description is known as the modeling. This modeling involves two different methods. One is in transfer function approach in frequency domain or S domain, and number 2 was state equations in terms of time domain. It says that apply fundamental any physical laws of science and engineering whichever you can for that particular system. It also says that whatever the equations we are going to write, that can be linear or non-linear depending on the phenomena being modeled. And in this context we wanted to say, or we wanted to define what linear system is. Linear system is that which obeys principle of superposition as well as the homogeneity. Now once we obtain the differential equation, it has been found that differential equations are inconvenient for analysis and design. So for that we wanted to use the Laplace transformations. I request the learners, those who are not in touch with the Laplace transformations, please go through the engineering mathematics book to have a quick look, quick review on the Laplace transformation, because it is very important to have a greater understanding, have a deep understanding on the Laplace transformation. Next is whatever the differential equations we have, with the help of the Laplace transformation, we convert those equations into simple algebraic equations. So when it becomes simple algebraic equations, it is very much easier to uh, solve or to reduce the equations. Then from these algebraic equations we go for the transfer function format. It says that this transfer function format, once we obtain, we proceed to the transfer function format block diagram, or alternatively to the signal flow graph. This all will be described in the later videos and which will be supplied in due time. So this series, the part 1, 2 and 3 are concerned with the approach of differential equations, transfer functions, block diagrams, signal flow graphs for different physical systems such as electrical, mechanical, hydraulic, pneumatic and the thermal systems. Please do remember, the ability and the precision of the results depends on how well the characteristics of each component can be expressed mathematically. So the next segment what we wanted to discuss is the differential equations of physical systems, which is very important and very first step to analysis or to analyze a system. It says that identify all the flow paths and the storage compartments of mass or energy in which the physical system is involved and describe quantitatively how the paths and compartments are connected. Once it is done, then there are different physical laws which are conservation of mass, conservation of energy, conservation of charge and Newton's law of motion. Check which law can be applicable on that physical system, and whatever the information it is available to the designer, he or she will try to write down few equations based on that physical law. Please remember that physical laws alone are not sufficient to describe the system completely. One designer has to take care of the fact that how the system components or elements are interconnected, as well as the empirically based description for some or all of the system components are needed to develop the equations for physical system. There is an important note for the learners that they are requested to listen the part 2 and part 3 to complete the mathematical modeling aspect of different physical systems, and they are supposed to attempt few graded assignments based on 3 parts during in-class activity which is scheduled in the next week. Thank you very much.